Pop's concert, Space, the Next Frontier, a celebration of NASA's 60th anniversary. Tonight, the Chromatics are made up of a group of scientists, engineers, and teachers that will take you on a rockin' a cappella tour of the known universe. Get ready to blast off with AstroCappella.
Thank you. We are so delighted to be here. We are so excited about NASA's first 60 years, and we can't wait to see what the future brings. This is a song that takes us from the past to today.
It was a calm and cloudless night, but it was all still a blur. The shaking of our universe was just about to occur. It was summertime, 1609, when Galileo used his telescope for the very first time, and he saw mountains and craters on the moon, and a Milky Way with thousands of stars, and he saw Jupiter with 4 tiny moons. He was the only man on Earth that night who knew that Copernicus was right. Come outside with me tonight, and I can show you wonders of the world to surprise and delight. I've got my telescope with me. Just wait until you see what's on the shoulders of giants to see beyond. The world turns round and round, and now around 400 years have flown since Galileo's telescope first focused the unknown. Now we use bigger glass to peer into the past, and we're discovering the universe's secrets at last. And there are geysers on Saturn's icy moon, and planets circling thousands of stars, while the universe expands like a balloon. From Galileo's tiny scope we've come so far. Galileo was right when he looked out in the night, and he discovered wonders of the world to surprise and delight. I've got my telescope with me. Just wait until you see we'll stand on the shoulders of giants, and every step follows the one before, and opens up a new frontier to explore. Our scopes are dancing in space to see the beauty and grace. Oh, Galileo would approve, that's for sure. And still for me and you, we can join in on this too. Just climb up here with me where we'll see more. It's a calm and cloudless night. Come outside with me tonight, and I can show you wonders of the world to surprise and delight. I've got my telescope with me. Just wait until you see we'll stand on the shoulders of giants. That Copernicus was right. Come outside with me tonight, and I can show you wonders of the world to surprise and delight. I've got my telescope with me. Just wait until you see we'll stand on the shoulders of giants. Shoulders of giants to see beyond. Thank you.
Oh, yay, Scott. That was Scott.
Good evening. Thank you all for coming. We're the Chromatics, and we're singing songs from our AstroCappella project in use in schools across the country, and as far as we know, across the known universe. In May of 1961, John F. Kennedy laid down a challenge that we would go to the moon before the decade was out, and NASA did that. We came through. I say we, I was about that height at the time, but I was really into the Apollo moon landings, and I followed everything. And I have had a thing for the moon ever since. This song is called Lunar Love. My love's a 250,000 miles away, and she's 7,000 miles around. When I'm walking on her surface, gravity's 1/6 of normal, so my feet don't hardly touch the ground. From her mares to her uplands, from her basins to her craters, she's the shining sphere that dominates my dreams. We're orbiting together round our center of attraction. Now my days and nights are coming up moonbeams. What goes around comes around. You know it. Don't tell me that my love is just a phase. You may think we're on the wane, but time will show it. We go from new to full to new in only 29 days. There's a craziness about our strange attraction. There's a side to you that I don't ever see. But your tidal forces keep my ecosystems running high. Let me shelter in your sea of tranquility. Let me shelter in your shining lunar sea. I'm not the only man this side of Mars to get my heart so dazzled by your charms. You've been the guiding light to many sailors and astronomers, but none of them has held you in his arms. Don't talk to me about our little difference in ages. What's a mere 4.6 billion years? They say you have no core, nothing solid at your center, and a lack of atmosphere just makes a girl so insincere. What goes around comes around. You know it. Don't tell me that our love is just a phase. You may think we're on the wane, but time will show it. We go from full to new to full in only 29 days. There's a craziness about our sweet attraction. There's a darker side to you that I don't see. But your tidal forces keep my ecosystems running high. Let me shelter in your sea of tranquility. Let me shelter in your shining lunar sea. Thank you.
The moon. What a great place it was to visit, we have been told. But many of us would like to find out for ourselves, so we were so excited that NASA is talking about going back to the moon, and really, really soon. And we know that they'll be driving Teslas on the moon now. At least we hope and think so. But you know, back in the 60s, they drove what they had in the 60s. So this is a song about moon roving, kinda.
Beep.
Beep, 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 beep. Beep, 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 yeah. Asked that girl what she wanted to be. And she said, baby, can't you see? I want to be famous, star on the screen. But you can do something in between. Baby, you can drive my car. You can drive my car. Yes, I'm gonna be a star. You can drive my car. Baby, you can drive my car. Baby, I love you, baby, baby. I told that girl that my prospects were good. And she said, baby, it's understood. Working for peanuts is all very fine. But I can show you a better time. Baby, you can drive my car. You can drive my car. Yes, I'm gonna be a star. You can drive my car. Baby, you can drive my car. Baby, I love beep, 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 yeah. Yeah, 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 yeah. Yeah, 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 yeah. Yeah, 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 yeah. Maybe, 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 baby. Baby, you can drive my car. You can drive my car. Yes, I'm gonna be a star. You can drive my car. Baby, you can drive my car. Baby, I love you. Baby, I love you. Baby, baby. I told that girl I could stop right away. And she said, listen, babe, I got something to say. I got no car and it's breaking my heart. But I found a driver and that's a start. Baby, you can drive my car. You can drive my car. Yes, I'm gonna be a star. You can drive my car. Baby, you can drive my car. Baby, I love you. Baby, I love beep, 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 yeah. Beep, 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 yeah. Beep, beep, beep.
Beatles space song. Who would have thunk it?
So the moon is the only other body that we have actually visited. People have actually stood on the moon. But we have visited every other planet in our solar system. As of just 3 years ago, we even visited Pluto. Although when the probe that was launched to Pluto, Pluto was a planet, but it's not anymore.
Well, how did that
It's very
happen?
confusing.
Michelle, can you help us out with this
I
one?
think I can help. I'm a big hot star, but it's not just me. I got a lot of little planets in my family. Sure, you know me well. I'm your stable, bright sun. But let's talk about my friends now. They're a lot of fun.
1, 2, 3, 4, 5, 6, 7, 8.
How many planets are circling in a plane? And everyone is different, now let me just explain. Rolling around on their orbits like the tracks for a train. Oh yeah, they're chugging around the sun again and again and again. One, two, three, four. Mercury's a hot spot, the sun is so close by. Venus like a diamond shining in your sky. Next is your home planet, the place of your birth. It's the solar system garden spot on precious planet Earth. Now Mars is red and rocky with some polar ice. It's a shame about the atmosphere. Could have been so nice. It could have been so nice, so nice. They're the terrestrial planets. 1, 2, 3, 4. But you gotta hang around, because there is still more. 5, 6, 7, 8. How many planets are circling in a plane? And everyone is different, now let me just explain. Rolling around on their orbits like the tracks for a train. Oh yeah, they're chugging around the sun again and again and again. Jupiter's a giant ball of gas like a sphere with a red spot. It's a storm that's rained for hundreds of years. Saturn in the night sky looks so bright and so little, but with a telescope you'll see a ring around the middle. Uranus is tilted on its side in the plane. Neptune's got another storm with chemical rain. They're the gas giants. 5, 6, 7, 8. But there's still more, so you better wait. Off at the edge, it's Pluto, our little caboose.
But everybody knows it's really not a planet now.
Maybe a slingshot round the giants almost set him loose.
He's just a giant in the Kuiper Belt.
Beyond that is a mystery about to unfold, with rocks and ice and chunks of things now very old. How many planets are circling in a plane? And everyone is different, now let me just explain. Staying in their orbits like the tracks for a train. Chugging round the sun again and again and again. 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 Woo, woo!
Well, that was planets, planets, planets. I like Mars, and it just so happens we were recently visited by two lovely aliens, two lovely Martian aliens right here, and they were very eager to teach us this Martian travel promo song, and we have a video too from them.
Come and visit Mars, you can have a lot of fun. We're right next to Earth, we're the fourth planet from the sun. Although we're half as large as Earth, we offer quite a lot. Huge mountains, craters, rifts, and storms.
Much larger than Earth's got.
Olympus Mons, a huge volcano visited, of course. 3 times as high as Everest, wide as Pittsburgh to New York. Bring a coat and bring a hat to bundle, if you please. Our temperature gets rather low,
Minus 200 degrees.
'cause our orbit is eccentric with our thin atmosphere, which you'll enjoy 687 days per Martian year. Just as a note of caution, it's not a big to-do. There's hardly any oxygen.
It's mostly CO2.
There's also not much pressure, so your body may explode. It's less than 1% of that of Earth, so wear the proper clothes. We hope you come to visit, and we hope it's very soon. We've Phobos and we've Deimos,
2 very lovely moons.
we're terrestrial, we're inner planet, not too far away. We see you've sent ahead some things, come pick them up someday. Come and visit Mars, you can have a lot of fun. We're right next to Earth, we're the 4th planet from the sun.
We are very excited that NASA is going to launch InSight in July, going to Mars. We keep going all over the solar system.
Yeah, unfortunately, that doesn't look like a very nice place to live. So unless we want our planet to look like that, we got to start doing something about that real soon. And that means recycling and reusing, and we're doing that right now with this song.
The problem is all inside your head, she said to me. The answer is easy thinking ecologically. I'd like to help you in your struggle to be green. There must be 50 ways to save your planet. Recycling's easy, you can't even make it pay. Reuse tomorrow what just looks like junk today. There's enough for all if we stop throwing it away. There must be 50 ways to reduce your eco-footprint. 50 ways to reduce your eco-footprint. Find a new use, Bruce. Sort out your trash stash. Put it out the curb, Herb. Listen to me. Compact and crush, rush. You don't need to adjust much. Just make a routine, Gene, and keep the world green. One problem is how to reduce our oil dependency. We need to find new forms of alternate energy. If we don't act, we'll face a global catastrophe. There must be 50 ways to reduce your carbon footprint. 50 ways to reduce your carbon footprint. Power from the sun, hun. Just harness the wind, Lynn. Geothermal is cool, Jewel. Listen to me. Coal is a crutch, hutch. You don't need to combust much. Just plant a new tree, Bree, and keep the air clean. Now when choosing how to get from A to B, some ways will lead to higher fuel efficiency. You'll save some dough and keep the planet breathing free. There must be 50 ways to reduce your carbon footprint. 50 ways to reduce your carbon footprint. Jump on your bike, Mike. Step on the train, Jane. Live near your work, Dirk. Listen to me. Hop on the bus, Gus. You don't need to bus much. No SUV lead. Just set yourself free. Here we go. Watch the meter spin back, Jack. Locally grown Joan. Share the ride, Clyde. Listen to me. Turn off the widescreen, Gene. Recycle that glass, Cass. Get out the lead, Fred. Just set yourself free. Use native plants, Lance. Turn down the heat, Pete. Purchase bamboo, Lou. Listen to me. Biodegrade, Wade. We're serving the Bay Ray. Unplug the machine, Dean. And keep the world green. Thank you.
Scott and Michelle are our newest members, and that song features them on our latest CD, Fragments.
So how many of you have ever looked through a telescope? Wow, that's really good. You guys must all be here for the NASA show. I remember looking through a telescope for the first time when I was in middle school, and there were all kinds of things they showed us, the Orion Nebula and Jupiter, but the thing that really caught me was Saturn. It was just so amazing, it was unreal. And that experience made me want to be an astronomer. And so this is a song about that. I used to look down once in a while, lift my head and look around. Not much to change my point of view.
What's new?
Not much. How about you? I used to see my small world, just the parts right in front of me. Why would I ever look for more?
Right here.
It's fine, that's for sure. Then you took me down a quiet road to a place I'd never been. Slid open the dome, dimmed the lights, and asked me to come in. Looking up, I could see a whole new world in front of me. The moon like a stepping stone.
As if the footprints on her surface were my own.
Through your scope, in the night, Saturn's rings were bold and bright. And for the first time I could see the universe light up for me. Venus and Mars seemed to me just the same as the distant stars. But then I looked at them anew and found a whole new point of view. Stunning and bright, Venus revealed, changing phases from night to night. The Martian ice caps ebb and grow. Seasons changing there, but how was I to know? It's a feeling that I can't explain. How the universe called me, like Galileo so long ago. The first night he could see, and I will never forget the moon in the twilight. Always remember how my heart took flight. Never see my same world through the same eyes. Now that I've seen the jewels sparkling in the night sky, looking up, I could see the universe in front of me. The moon like a stepping stone.
As if the footprints on her surface were my own.
Through your scope, in the night, galaxies all swirls of light. And for the first time I could see the universe light up for me. And now I know that I can see to the edge of infinity.
Yeah, that was Karen.
Patty wrote that one.
If you're looking for us on the internet, we're at www.thechromatics.com. And if you're specifically looking for the AstroCappella project, we're at astrocappella.com. If you're looking for us after the show at 7 p.m., we'll be over there, just at the end of the area there, and we'll have some CDs if you're interested. Meanwhile, when you're traveling through the solar system in your spacecraft, It is vitally important to be able to tell the difference between the comets, the meteors, and the asteroids. This song will help you. This is a little bit of rock.
1, 2, 3, 4.
Hey baby, I'm the shooting star, a blazing racing tracer in the sky. I'm heading for a surface 50,000 miles an hour. Gonna hear my sudden impact, gonna feel my power. Catch you later when I crater. I'm just a little bit of rock.
Small bodies were the meteors. There's one of us who wiped out all the dinosaurs. We're icy bits and comets, we're iron and we're rock.
Streaking through the sky, we're in atmospheric shock.
Hey baby, I'm a rock in space, a tumble jumbling body in the sky. Between Jupiter and Mars I make my presence felt in a band of rocky relics called the asteroid belt. Pallas, Ceres, Vesta, and many thousand bits of rock.
Small bodies were the asteroids, a mess of planetesimals that swinging in the voids. Chunks of past collisions or a tiny world unformed. Watch out for the earth crossers, you have been warned.
Hey baby, I'm a hunk sublime, an icy dirty snowball in the sky. Gases streaming from my nucleus give a nighttime treat. I'm a dropout from the Oort cloud with a regular beat. Eccentric in my orbit through the solar plane. Pass too close to sunward and I'll never be the same.
Small bodies were the comets' hunt, tails forever trailing out away from the sun. Hayakataki, Heli, and a bit of hail bop. SL9 hit Jupiter, that show was not a flop.
Rocking round the system with small bodies right, where asteroids and comets are difficult to sight. If we plunge into your atmosphere, we'll set the skies alight. And where meteors and fireballs will glimpse us in the night. Just a little bit of rock. Thank you.
That was by Dr. Alan Smale himself.
So when I first moved here from Colorado, yes!
You've heard of it.
I had a job working on a solar satellite, not on the satellite. I worked for the Solar Maximum mission when I first started, and I did a lot of solar physics prediction. I don't do that anymore, but we have solar satellites that are going and observing the sun all the time now. At the time, that was the only one, and it was serviced by the space shuttle, actually. It was the very first satellite to be serviced. And we've had stereo, and next we're launching, and solar probes, yes, we got tons. Next, we're launching the Parker Solar Probe, and that one is going to get closer to the sun than any solar observing satellite, or maybe any satellite at all, has ever done. And it will be orbiting 10 times closer to the surface of the sun than Mercury is, and Mercury is the closest planet in there. So it's going to spend some time, maybe 7 years, getting to that orbit by doing some maneuvers with Venus, getting really close in with the gravity assists. So anyway, this is a song all about the sun.
I saw the sun is a big ball of gas, and it's 99% of our solar system's mass. It's an average star in our Milky Way, warming the earth every day. What powers our sun and makes it so bright?
Come on and tell me what makes all that light. Hans Bethe long ago reached the conclusion
It changes hydrogen to helium by nuclear fusion. When fusion takes place, light is created,
and it makes its way out
although rather belated.
through the photosphere. That's the part that we see. The light comes out
And shines on you and me. About 1 million Earths could fit in the sun.
But if you were there, you wouldn't have much fun.
It's 6,000 degrees at the photosphere.
And much hotter inside the solar atmosphere.
There are
are a few places where it's not so hot.
Like at the center of a big sunspot.
But heat is relative, it's still pretty warm.
Sitting on a sunspot would do you great harm. Ba-ba-da-ba-ba-ba-ba-ba-da-ba-da-ba-da. Galileo discovered sunspots. What are those things, those funny dots?
They're cooler parts, scientists feel,
Caused by a stronger magnetic field. The spots move around the face of the sun, proving to all solar rotation a strange kind of movement to do a full roll.
25 days in the middle, 36 at the pole.
What about flares? I've heard of them here. They're like giant explosions in the chromosphere.
the magnetic fields above the sunspot.
Reconnecting again after being in knots above the chromosphere. The corona is placed. It's millions of degrees and reaches way into space. It's very thin, but read my lips. That's the part that you'll see in a solar eclipse.
That's the end of our song about Mr. Sun.
We hope that you find that learning is fun, but never look at the sun. You could go blind. Just keep on enjoying that warm sunshine.
Oh,
Thank you.
It is a sunny day today, isn't it? It's not
Sun-
raining. Is it raining?
Oh, yeah.
Sunny and warm, not raining yet. We have a
Yay.
beautiful planet around a beautiful star with a beautiful habitable atmosphere. Habitable atmosphere, a place where it's not too hot and not too cold, but just right for liquid water to pool on the surface. So far, it's a very special place in our solar system. But one of the most exciting things that's happened in the history of NASA is that we've gone from a time where the only planets that we knew about in the entire universe were the ones that orbited our sun. So we've known about our solar system for hundreds of years. Mercury and Venus interior to us, Mars and the other gas giants and beyond, Pluto, rocks all the way out to the edge. But we had no idea if the other stars out there had planets like ours. It was a big mystery. It was a really hard problem to solve because planets are teeny, teeny, tiny compared to their star. The light from the Earth is about 1/10 billionth the light of the sun. So the sun's 10 billion times brighter than a planet like Earth. That's a really, really hard problem, folks. But scientists work really, really hard to try to make their dreams into reality. And today, as NASA turns 60, we now know of well over 4,000 planets around other stars. 4,000 exoplanets. So this is a song about the journey from none to thousands and thousands, and just think where we might be in another 60 years. When I was a child, I tuned in to a beautiful fantasy. Humans and Vulcans at peace in the cosmic community. I'd look up to the sky at night, and I'd ask myself, could it be right? Are there planets like ours around faraway stars? Or are we all alone on our planet Earth home? Are we whirling around imperceptibly, caught up in the dances of gravity? A random galactic anomaly, 9 planets around the sun, spinning and swirling, twirling and whirling around the sun. Time marches on and astronomers hone their technology, point their scopes to the sky with an eye to unraveling a mystery. And like the faintest of coals in the night lies a signal within a star's light, like a beacon of hope in your burnt umber sky. The rising of 51 Pegasi, dancing almost imperceptibly, backward and forward from gravity. a companion of closest proximity, a planet around a star. At the edge of the galaxy, clusters of stars, their members a billion years older than ours, hold wobbles of planets around their pulsars. They've had eons more time than we. Is it possible? Could it be? Am I watching you, watching me? And at the dawn of the 21st century, the dream has become a reality. We're not quite as alone as we used to be. There are planets around the stars, planets around the stars, spinning and swirling, twirling and whirling around the stars. Backward and forward, they're coming and going around the stars. Daytime and nighttime, summer and winter, around the stars. We finally found them, there's planets around them, around the stars. Thank you. Well, NASA launched Kepler 9 years ago now, and it's still going strong. And it also just launched the second exoplanet mission called TESS, the Transiting Exoplanet Survey Satellite. It's still being checked out, going to start science this summer. So stay tuned for TESS.
So as you all know, I'm sure, NASA has been around for 60 years, and they're celebrating all of the wonderful accomplishments that they have made. And one of the really great things that we've found are all of the planets out there. Just like Patty was talking about, we've found so many planets, but have you ever wondered what it is that the scientists use to find all of those things out in space? And one of the ways that we do that is through the spectrum of light that we can observe here on Earth and through our vast telescopes. So here's a song that explains a little bit more to you. Susan cruising down the freeway doing 78.
Go speed racing, go speed racing.
She just likes to drive fast, it's not that she's late.
No tailgating, no tailgating.
Goes over a hilltop and what a surprise.
Too late, sister, you're in for it now.
Blue and red flashing lights right in front of her eyes. Now Susan's standing by the side of her car.
Show me your license, you're in big trouble.
Truck's blowing right by her, but she's not going far.
They're still cruising, Susan's a losing.
She's been caught by a speed trap, and now she can hear.
Here comes the physics, you're in for it now.
Sound of the Doppler shifter right in her ear. That's the Doppler shift.
You've heard it, I know. Doppler shift, first it's high, then it's low.
The good cop's gun shoots out only radar, and the beam bounces back off bad Susan's car. And assuming the policeman is standing in range, his gun tells him all about the frequency change. And Susan's walking, her speed racing days are done.
Yeah, I've heard that on Earth, but how's that gonna work in space?
Oh, just you wait. They're light years away, man, and that's pretty far.
Light speed's the limit, the big speed limit.
But there's plenty we can learn from the light of a star.
Split it with a prism, there's little lines in it.
By looking at the spectrum of the light that's glowing.
Wavelengths of emission, measured with precision.
Its Doppler shift will tell us if it's coming or going.
Do, 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 do.
That's the
Doppler shift, you see it, it's true. Doppler shift to the red or the blue.
When a star is approaching and it's coming our way, its spectrum seems blue, or won't you hear what I say? And when a star's retreating way out of range, and the scientists measure its frequency change, well, that's a red shift if the star is moving away.
Ah, Michelle, you took us to the stars. Now take us to the galaxy.
And beyond. By reading Doppler shifts of what we see in the sky,
galaxies near and far.
We get the big picture and a big surprise.
Redshifts going, redshifts going.
The universe is growing and expanding away.
Galaxies are speeding, speeding away.
But maybe gravity will shrink it back someday.
Are we Doppler shift to the red or the blue? Doppler shift and our shift's overdue.
Now blue shifts come and red shifts go, and that's pretty much everything you need to know. Now we're gonna pick up Susan and give her a ride, so you guys remember Doppler and you drive to survive. And now we're shifting, and our Doppler song is done.
So, can you count HST?
Thank you, Michelle. Michelle is a teacher, so she teaches math and science and music every
She knows
day.
all this stuff.
Because I know these guys.
Yay, teachers.
Yay, teachers.
So none of us would be here without teachers. None of us would be here without inspiring role models. People would not be launching telescopes into space if it hadn't been for really, really inspiring teachers. So thank you, Michelle, and all teachers. You know, there's a lot of telescopes out there in space. But there's one in particular that most people have heard of all over the world. Can anybody tell me what telescope they think that might be the most famous? Hubble! Yes! Hubble got you. Hubble Space Telescope was launched in 1990, so it's been around 28 years, a huge fraction of NASA's history. Many of us remember the days before it launched in the early days of Hubble. It's really transformed the way we look at the universe. It has allowed us to see things we could not see with our own eyes. It has allowed us to peer into stellar nurseries. It's starting to peer at exoplanets and give us fingerprints of the building blocks of their atmospheres and how they're composed. And it's going strong. It may be here in 2020. So Hubble has 2020 vision and beyond. And this is a song that talks about some of our favorite things that Hubble has seen.
Well, I see you every night before I sleep. There's a poster on my wall about your field so deep. A telescope in space studies cosmic mysteries from nearby planets to distant galaxies. HST. Do you want to see the things that no one else has seen? Well, then come and take a look through our time machine. Hey, theorists say some sides are black, when light goes in but never does come back. HST. Bow, 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 bow. Black holes, Cepheids and quasars, brown dwarfs, giants and pulsars, fornax, the Virgo cluster, supernova, baby star, comas, nuclei, ice trail, hail, bop, ion and dust tail, co-star, corrected your vision. HST.
HST is the Hubble Space Telescope, NASA's premier space astrophysics mission, observing in the visible, infrared, and ultraviolet wavelengths. Launched into low Earth orbit by the Space Shuttle in 1990, it has been observed 5 times by astronauts on daring shuttle missions to ensure its continued legacy of breathtaking discovery for years to come.
Do you want to touch the edge of both space and time? Do you want to know the origin of your world and mine? Hey, then find your library or CPU. Switch on the TV, ask your teachers too. HST. Bow, 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 bow. Black holes, Cepheids and quasars, brown dwarfs, giants and pulsars, fornax, the Virgo cluster, exoplanet, Martian storm. Nail down the Hubble sing. HST. Bow, 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 bow. Black holes, Cepheids and quasars, brown dwarfs, giants and pulsars, Fornax, the Virgo cluster,
Exoplanet Martians.
nailed down the Hubble constant. Redshift measures the distance. Find out what you've been missing. HST. HST.
Thank you, Cyndi Lauper.
HST tells us all about what's going on in the optical, but very important things happen in the X-ray and gamma ray wavelengths as well. At those high energies, we see all kinds of emission from neutron stars, from black holes, from the sun, from active galactic nuclei, really large black holes in the center of other galaxies. X-ray astronomy is actually really important to the whole field of astronomy, and we're going to sing a little bit about that now.
Importantly, you can only see those X-rays and gamma rays if you launch a telescope into space.
Yes, that's correct. And so all of our observing has to be done from above the atmosphere, with things like the Rossi X-ray Timing Explorer that was up there for many, many years, and many things that are coming up in the future.
X-rays, gamma rays, high energy. Hot stars, heavy stars, high density. Quasars, black holes, supernovae. Powerhouses lighting up the galaxy. Flashing, bursting, pulsing objects we could see if we had X-ray eyes. If we had X-ray eyes. Hot photons, those hot photons. Hot photons, those hot photons.
Going up the spectrum, repeat after me. Radio, infrared, visible UV. Keep going all the way, and what do you see? That's X-rays, gamma rays, those high energy. An X-ray photon has a high frequency, which means a shorter wavelength than you could ever see.
High energy radiation. High energy radiation.
X-rays come from various processes, like a cloud of gas above about 1,000,000 degrees, or magnetic fields that send electrons swarming like these, or even neutron stars emitting like black bodies. And you get X-rays from stars, stuff that came near to and fell into a black hole's gravitational potential wave.
Shortwave.
If we flew above the atmosphere and looked out at the skies, and if we could do it with X-ray eyes, you'd see more flashing and popping than you realize. Objects winking on and off like fireflies. The X-ray sky isn't calm and quiet. It's more like a rockin' high energy riot, yeah. X-rays, gamma rays, high energy. Hot stars, heavy stars, high density. Quasars, black holes, supernovae. Powerhouses lighting up the galaxy. Flashing, bursting, pulsing objects we could see if we had X-ray eyes. If we had X-ray eyes. X-rays can show you the roots of your teeth. Shine them through your body, see the bones underneath. But don't go thinking that we X-ray the stars, 'cause they're billions of miles away, much too far. We collect all the X-rays that they send to the Earth, telling tales of star death, giving hints of starburst.
X-ray binary stars. X-ray binary stars.
Here's a story of a pair of stars called Cygnus X1. One's a black hole many times the mass of the sun, with a disk of gas surrounding it, spiraling in, sucked from the companion star's outermost skin. We see the high-speed flickering as star stuff flies in, a one-way trip beyond the event horizon.
High-frequency flash. High-frequency flash.
Cosmic lighthouse flashes in space. It's an X-ray pulsar with a regular pace. A neutron star 30 miles around at best, spinning round its axis once a second or less. And way beyond the Milky Way, the active galaxies are the furthest, biggest things our X-ray eyes can see.
High-frequency flash. High-frequency
fancy flag.
Point your X-ray specs towards the sun's location. You'll notice that along with its slow rotation, you'll see active loops and plasma arcs in a solar dance producing X-ray sparks. The X-ray sun isn't serene and smooth. It's a dynamic and changing high energy groove.
High energy groove. High energy groove.
X-rays, gamma rays, high energy. Hot stars, heavy stars, high density. Quasars, black holes, supernovae. Powerhouses lighting up the galaxy. Flashing, bursting, pulsing objects we could see if we had X-ray eyes. If we had X-ray eyes. Thank you.
That was another one by Patty Boyd herself. Oh, it's been a long, long time since that first telescope that I sang about at the beginning of the show. It's been 400 years. And since then, our technology and our ability to build bigger and bigger telescopes has allowed us to see further and further back into time and space and discover more and more things. And in 2 years, the largest space telescope ever built, the James Webb Space Telescope, will be launched into space. It's going to be 6 times bigger than Hubble. It's going to have 100 times the sensitivity, and it's going to see to the furthest reaches of the observable universe. 1, 2, 3, 4. Get up.
Get on up.
Get up.
Get on up.
JWST.
Get on up.
Launching into space
Get on up.
in 2020.
Get on up.
It's a time machine.
Get on up.
Let's do it.
Hey!
Hey! 6 meter mirror on a 1,000,000-mile trip, observing an infrared wavelength to reach the highest redshifts. It'll be the biggest telescope in space. It's gonna see 13 billion light years away. The James Webb Space Telescope launching into space in 2020. It's a time machine.
6 times larger than
HIST.
32 megapixel camera and
Spectroscopy.
cool clear absolute zero.
-400 degrees.
For best image quality.
More self-emissivity.
From planets in our solar system to the early universe's conditions, the James Webb Space Telescope.
Interstellar dust clouds block all sorts of light, but in mid-infrared wavelengths, the universe is clear and bright. From the end of dark ages to the very first light, reionization will be quite a sight.
JWST launching into space in 2020. It's a time machine.
With the infrared camera, we'll see the first stars start to shine, and we'll see clusters and galaxies, the universal building blocks all combine. We'll study black hole morphology and redshifts very high, dark matter distribution and protostars just come into life.
Active dark windows block out bright stars in view, so we see distant faint objects and measure spectra of them too. By viewing only objects that we want to see, we'll split light from 100 targets simultaneously.
JWST launching into space in 2020. It's a time machine. Let's wrap it up.
J-Dub is more than just the first galaxies. It'll study nearby exoplanets, possible local homies, by phasing out bright starlight with interferometry. We'll observe orbiting planets and be able to see their atmospheres as they pass in front of their stars and capture light that's not absorbed by things like water vapor.
That's the telescope we call JWST, launching out of this world in 2020. It'll be the biggest telescope in space. It's gonna see 13 billion light years away. The James Webb Space Telescope.
James Webb Telescope.
That'd be awesome.
Well, there's so much other exciting things that NASA has yet to do. We've been so happy to be here at the Millennium stage to sing about some of our favorites. The universe is a big place. Time is everlasting and expanding, so we're very excited about the future. We only have 1 or 2 more minutes left, but we're going to try to sing about everything else.
Cram
out
it
there.
all into 2 minutes. We'll sing fast, folks.
Our whole universe was in a hot, dense state. Then nearly 13 million years ago, expansion started. Wait. The earth began to cool, the autotrophs began to drool, Neanderthals invented tools, we built a wall, built the pyramids, math, science, history, unraveling a mystery that all started with a big bang. Since the dawn of man, it's really not that long. The seeds of galaxies were formed in just the time it takes to sing this song, a fraction of a second, and the elements were made. The bipeds stood up straight, the dinosaurs all met their fate. They tried to leap, but they were late, and they all died. They froze their feathers off the oceans, and Pangea wouldn't wanna be a set in motion by the same Big Bang. It all started with a Big Bang. It's expanding ever outward, but one day it may pause and start to go the other way, collapsing ever inward. We won't be here, it won't be heard. Our best and brightest figure that it'll make an even bigger bang. Except we forgot all about dark energy, a mysterious force that's everywhere in the universe at all times. NASA's gonna launch a telescope called WFIRST to study this mysterious force. It's pushing the galaxies apart at an ever-increasing rate. We're actually in an accelerating universe, and we're never gonna collapse back on ourselves. At least that's what we're thinking these days. Australopithecus would really have been sick of us debating why we're here. They're catching deer, catching viruses, religion and astronomy, Descartes and Deuteronomy. It all started with a Big Bang. Music and mythology, Einstein and astrology. It all started with a Big Bang. It all started with a Big Bang.
Thank you.
Thank you very much. Come talk to us after the show. We'll be in the back.
Thank you.
Thank you so
Thank you,
much.
Thank you very much.
Happy birthday, NASA.
Thank you for joining us at Millennium Stage. As we prepare for another performance, we ask that you help us by heading towards the back of the seating area so we can safely put away our chairs. If you would like to meet with the artists, they'll be in the back at the merchandise table. Thank you, and we hope you enjoy the rest of your evening at the Kennedy Center.